Hi and Assalamualaikum warahmatullahi wabarakatuh. So today we are going to present our video for this case study with the topic that we have choose, which is gas chromatography. So this is our group members. The first one is HAIQAL bin ZULKURNAIN, Muhammad ZIKRI bin MOKHTAZAR, me myself Muhammad ZUHAIRI bin ZAINUDDIN, SYED Muhammad NORSYAHIR ZAMIR, and one ABDUL HAYYI bin one AZIZ. So for the introduction, gas chromatography is one of the most often used in chromatography technique for separating volatile molecules or substance. Gas chromatography has become one of the most essential due to its simplicity, high sensitivity and ability to successfully separate mixture. So the mobile phase for the gas chromatography is inert gas and the stationary phase is solid or liquid. So next is concept of gas chromatography. So the first one is stationary phase. So stationary phase is the material coating the chromatographic column where separation occurs. The second one is retention time. So retention time refers to the time taken by a compound to travel through the chromatographic column and reach the detector. The third one is carrier gas. So carrier gas is the inert gas, for the example like helium, that carries the sample through the column. The fourth one is detector. So we have three detectors, which are flame ionization detector (FID), mass spectrometer (MS), and thermal conductivity detectors (TCD). Next is chromatogram. So chromatogram is the graphical output of the gas chromatography analysis, showing peak representing separated compounds. Parameters like peak height provide information about the quantity and purity of the compounds. And the last one is peak separation. So peak separation is the compound elute from the column at different times, creating distinct peaks on the chromatogram. Next, we are moving to principle of gas chromatography. Okay, so for the principle of gas chromatography, a sample is injected into the injector and vaporized into the chromatographic column. The flow of the inert gases mobile phase transport the sample through the column. As the sample goes through the column, it is separated and electronically detected by a detector.
Assalamualaikum. I will be explaining about the objective of our video. The first one is to explain the principle of gas chromatography. The second one is to demonstrate the method and procedure of gas chromatography experiment. One is to identify the factors affecting retention time and explain what can be done to ensure good result from a chromatogram. And lastly, to show the result of sample separation and content using GC or gas chromatography.
Okay, for methodology, to perform a gas chromatography, often called GC, we use a gas chromatograph. It is an instrument with a long column filled with a small particle loaded with a very thin layer of an absorbance. This layer is the stationary phase of the column. To run a GC, you need first to prepare the sample for injection. Using a small syringe, collect between 1 and 5 microliters, follow with the 3 to 4 microliters of the air. Be sure that your sample are free of drying agent from clogging the syringe. Insert the syringe into the GC injection port. Remember not to bend the syringe in or out. Then turn on the check recorder. Make sure it is recording and wait until the entire sample run through the column. For now, wait for the result and don't forget to clean up your syringe with a solvent such as a methanol. That's it for methodology. Thank you very much.
Assalamualaikum, and I will continue with the result of the experiment. And this is the experiment of chromatograph under 3 degrees Celsius. The first compound identified is acetaldehyde, ethyl acetate, methanol, ethanol, and 1-butanol. The retention time of acetaldehyde is 1.81, which is the highest mobility of the element. And next is ethyl acetate with 3.41, methanol with 3.55, ethanol 4.21, and the retention time of 1 butanol is 8.01. And next, we continue with selective factor. Acetaldehyde with 4.14, ethyl acetate with 1.07, methanol with 1.29, and ethanol with 2.31. And next, resolution for acetaldehyde, which is 26.67, ethyl acetate with 2.55, methanol with 11, and ethanol with 54.29. Selective factory and resolution for 1 butanol is not shown because 1 butanol has the highest reaction with stationary phase. As for the chromatogram above, the first compound that elute is acetaldehyde, which is the retention time of 1.81, and the peak showing that the concentration of the compound. And next, we have ethyl acetate, which is 3.41, and the peak showing that it has the highest concentration. Then the other compound, and it followed by methanol, which is 3.55, and the peak showing that it has the lowest concentration than the others compound. And then we have ethanol, which is 4.21, and then 1 butanol, which is 8.01, which is showing that 1 butanol is lower concentration than the ethanol.
Assalamualaikum, my name is ZULKURNAIN. I'll be explaining the discussions for our video presentation. So why is it that the order of elution is sorted out the way that it is? In gas chromatography, the order or rate of elution is dependent on multiple factors, such as the polarity of the column, the boiling point of the sample components, column temperature, and the flow rate of the gas. However, we will only focus on these 3 points in our discussion, which are the polarity of stationary phase and sample components, the boiling point or volatility of the eluents, and the column temperature. Okay, so for the first factor, I'll explain about the effects of polarity on the column and sample components. So if the column and sample components are both polar or non-polar, they'll both want to stick to each other. This causes the rate of elution to be very slow because they wouldn't want to decouple from each other. On the other hand, if the stationary phase of the column is polar and the sample components are non-polar, the sample components will instead be carried away by the mobile phase, ensuring that it is eluted properly. Besides that, the column temperature also has an effect on elution and the resolution. So if the column is at a high temperature, it makes for a faster rate of elution but gives a lower resolution. It produces peaks that are not very well separated. But if the column is at a lower temperature, the elution is much slower but the resolution is higher, meaning that the peaks are well separated. So in order to get us the best of both, we must use a temperature that is above or the same as the average boiling point of the sample in order to get a reasonable elution period along with good resolution. Besides that, the volatility of the sample components themselves also has an effect on elution. Different components of the samples have different boiling points, so that means that they elute at different rates depending on the column temperature. A higher boiling point means a higher temperature is needed to make it elute faster, and the opposite is also true. Using our previous chromatogram, we can see that acetaldehyde eluted first while 1-butanol eluted last. By looking at the boiling point table, we can see that this theory roughly checks out. The sample component with the lowest boiling point eluted first, while the sample component with the highest boiling point eluted last. Finally, we return to our original chromatogram. So, how do we improve it? There are two problems here. There is poor separation for ethyl acetate and methanol, and 1-butanol elutes very late at 8 minutes. So, the solution is simple. We must use temperature programming instead of an isothermal run. This is done by setting our column temperature to be low to elute the components with low boiling points first. And then, we increase the temperature to elute the components with higher boiling points faster. That way, the chromatogram will be more compact as the order of elution follows the boiling points of the components, and the time taken to elute all the components is much shorter than an isothermal run. Okay, that's all from my part. I'll be handing this over to the next groupmate.
Gas chromatography has been proven to be an important tool within scientific study due to its ability to determine volatile compound with accurate result without breaking the molecules. It can be used in environmental analysis, pharmaceutical, and so on in many other fields. Therefore, this concludes our video for now.